Let us try to understand how to find out the beam reaction in case of simply supported beam carrying the inclined load using the graphical method. As shown over here, we are having the beam PQ, which is loaded in such a way that there is a hinge support at the left hand end and roller support on the right hand side. So it is having the vertical load of 15 Newton, but the another load of 10 Newton is acting at an angle of 60 degree. So whenever we are having the inclined load, because of this inclined load, the reaction at point P, which is hinge, will also be inclined, and we have to find out the magnitude and direction of this reaction acting at point P and reaction which is acting at point Q. As this is the roller support, the reaction over here will be perpendicular to the roller surface. So here the roller surface is horizontal, so reaction will be vertical. Now let us see the procedure for drawing this particular graphical construction. Now we'll use the Bow's notation. So as you can see over here, this A, B, C and D, these are the Bow's notation. This AB represents this 15 Newton force, BC represents this 10 Newton inclined load, CD will represent the reaction at this particular roller support, then DA will represent the reaction at this particular hinge support. Let us take any point O, which is known as the pole, and then start drawing this particular diagram. So just now we have seen that this AB represents 15 Newton force. So suppose we take the vector diagram scale as 1 centimeter is equal to 5 Newton, then 15 divided by 5, that is 3 Newton. So this particular length, this particular vector that we have shown over here, which is parallel to this 15 Newton force, will be of 3 centimeter. Similarly, we'll draw the another vector which is parallel to this particular 10 Newton force. So 10 divided by 5, so that is 2 centimeter. So this length will be of 2 centimeter. So we can say that this AB has to be 3 centimeter, this BC has to be 2 centimeter. Now join this with O. So we have obtained the various rays over here. So OA, OB and OC are the various rays which we have obtained by joining this particular ABC points with O. Now draw a line parallel to this OA in the space of A. So this is the space of A, this entire is the space of A. So in the space of A, draw a line parallel to this OA. Similarly, in the space of B, draw a line which is parallel to this OB. So as you can see over here, this is OB and we have drawn a line parallel to this OB. Similarly, in the space of C, draw a line parallel to this OC. So this line we have already drawn over here. Now close this particular polygon. So this is known as the funicular polygon. So we have closed this polygon. So this is known as the closure. And please remember that this diagram we have not drawn to the scale. In the next slide we will see how this particular diagram is drawn to the scale and how to calculate these reactions. Now draw a line parallel to this particular closure from A. So this is the closure and draw a line parallel to that particular closure. Now draw a vertical line from point C, because we know that the roller support, the reaction at this particular roller support is vertical. Wherever these two intersect, that will give us the point D. Now join D with A. So we can say that this particular CD, as per the Bow's notation, CD represents the reaction at this particular roller support and DA represent the reaction at this particular hinge support. So we can say that this CD will represent the reaction at the roller support and this DA will represent the reaction at the hinge support. The scale that we have chosen for the space diagram is 1 centimeter is equal to 1 meter, and for vector diagram it is 1 centimeter is equal to 5 Newton. Now let us see the actual diagram over here. So as you can see over here, the various dimensions, we have drawn this particular on our graph paper. So this AB is of 3 centimeter representing 15 Newton force. This BC is of 2 centimeter representing this inclined load which is acting at an angle of 60 degree. Then this particular will represent the reaction at roller support and its value is 2.12. Then this dA will represent reaction at hinge support and its magnitude is 2.78. So this is the closure and we have drawn a line parallel to this closure and then the vertical line as we have discussed earlier, and then we have joined this dA to obtain the respective reactions. Now let us see what are the magnitudes of this particular reaction. So as we have seen earlier that this CD represents RQ and this dA represents RP. So reaction at P, this RP is inclined, so this is the reaction which is inclined. So if you draw that a line parallel to that over here, this reaction is inclined and its direction is 67.63. It makes an angle of 67.63 with the horizontal, and its magnitude is, you have to measure this particular length, the magnitude is 2.78 multiplied by the vector diagram scale, that is 5. So RP is nearly 13.9 or nearly 14 Newton. Similarly, reaction at Q, so RQ is given by this CD, its magnitude is 2.12 multiplied by the scale, that is 5, so it is 10.6 Newton. So in this way we can find out the reactions at the support using the graphical method. Thank you very much for watching.